In this next video, we are going to look at tree diagrams and Venn diagrams. What is a tree diagram? A tree diagram is a special type of graph used to determine the outcomes of an experiment. So here's an experiment. The first event is flipping a coin, and then the second event is rolling a die. Now, when the coin is flipped, there are only two possible outcomes, head or tail. And so, or heads or tails. Each one is 1/2 probability. Once you've flipped a heads, if the second event has to do with whether you have a 6 or not, then you have a 1/6 chance of getting a 6 and a 5/6 chance of not getting a 6. You can repeat these same two scenarios down here, so that if you want to know the probability of first flipping tails, then rolling a 6, the outcome would be tails and 6, and we would then multiply the 1/2 on the green line and the 1/6 on this green line together to get 1/12. So these branches are going to be labeled with either frequencies or probabilities, in this case probabilities. For some people, the tree diagram is the easiest way to visualize probability. It's limited in what it can do, but we're going to look at it a little bit in this course because it can be very helpful. John Mark wakes up late on average 2 days out of every 8. If John Mark wakes up late, the probability that he is late for school is 0.6. If he doesn't wake up late, the probability that he is late for school is 0.3. Create a tree diagram by entering the probabilities and then calculate the probability that John Mark gets to school on time. So, first of all, our scenarios are, does John Mark wake up late or on time? Then, given that he wakes up late, or given that he wakes up on time, does he arrive to school late or on time? So there are 4 different possibilities, right? He wakes up late, he gets to school late. He wakes up late, he gets to school on time. He wakes up on time, he gets to school late. He wakes up on time, he gets to school on time. Now each of these A, B, C, D, E, F, you would then label with probabilities. We are told that John Mark wakes up late on average 2 days out of every 8. So his late waking up is 2 out of 8, otherwise known as 0.25. Then his on-time waking up would have to be 6 out of 8, or 0.75. So those would be the labels then for A and B. Next, for C and D, we want to look at this second sentence here. Or sorry, the second sentence is, if John Mark wakes up late, this is this scenario right here, we're looking at C and D, the probability that he is late for school is 0.6. So that means that the C value is 0.6, but the remainder of that, the 0.4, would apply to on time. Third sentence, if he doesn't wake up late, that would be this scenario down here, the probability that he is late for school would be 0.3. So E is going to be 0.3, and that would make F 0.7 because, again, these two have to add up to 1. And as these add up to 1, as these add up to 1. So now we're trying to calculate the probability that John Mark gets to school on time. There are 2 ways to get to school on time. Wake up late and then go to school on time. Wake up on time and then go to school on time. So let's look at each of these. John Mark wakes up late and gets to school on time is going to be 0.25 from A, and then 0.4 from D. You multiply 0.25 and 0.4 together and you get 0.1. Second scenario, John Mark wakes up on time and gets to school on time. We're going to multiply the 0.75 for B and then the 0.7 for F together, and you get 0.525. Add those two situations together, and you've got a 62.5% chance that John Mark is getting to school on time. Question 23. When shooting 2 free throws, the chance of a basketball player makes her first free throw is 60%. If she makes the first one, she gains confidence when she gains the second shot, while if she misses the first one, she gets nervous and therefore would miss the second one too. Alright, so we're going to make a tree diagram. And how are we going to label these branches? Well, in the first case, on the first shot, she can either make it or miss it, right? And then on the second shot, again, she can either make it or miss it. So we've got first shot represented by the first branch, and then these second branches are representing the second shot. So now you can have a make, miss, make, miss. So now we're going to use these values here to fill in the information. 60% is making the first free throw, so that would be 60% here on this branch, and 40% would then be missing it. So now we need more information for what happens when she gets nervous on the second shot. If she makes her first free throw, there is a 70% chance that she will make her second free throw. So then we put 70% here for making the second one, and that would mean 30% for missing it. Next situation. If she misses her first free throw down here, there is only a 40% chance that she makes her second free throw. So we've got 40% for makes and 60% for misses. So this one on My Open Math, you're not going to be filling in a tree diagram. You're going to be just drawing one on your own and then using it. You don't have to turn in the tree diagram for this problem, but you might have to do it on the test. So definitely try to practice the tree diagram for this problem. Okay, what is the probability she makes both free throws? Makes is going to be 0.6 times 0.7, right? Next situation, what is the probability she misses both? Miss is going to be 0.4 times 0.6. You just follow the branches and multiply these events together. What is the probability she makes exactly one of the 2 free throws? Exactly one of 2 means that she has to make it and then miss it, or misses it and then makes it. And those are mutually exclusive. So once you figure out the makes and then misses combo, which is 0.6 times 0.3, you would then add that result to the misses and then makes, which is 0.4 times 0.4. Okay, probability of makes then misses is going to be 0.18. Probability of misses then makes 0.16, so that's a 34% probability that she makes exactly one of the 2 free throws. In this last scenario, she makes, what's the probability that she makes at least one of the free throws? Remember, that's going to be the complement of missing both. Missing both is 0.4 times 0.6, which is the 0.24. Hence, to make at least one of her free throws, she has a 76% chance. And that now brings us to Venn diagrams. A Venn diagram is a picture that represents the outcomes of an experiment. So, the box around the circles, around the Venn diagram, would represent the whole sample space. And looking just at this picture, let's try to imagine probability events that correspond to this Venn diagram. So I'm thinking there were some people and they were asked whether they like apples or oranges or both. And how many people are there here total? 23 plus 10 plus 20 plus 7. That's 60 people. So maybe 60 people were asked if they like apples or oranges. Maybe this represents the 7 people who didn't like either. The 20 here could be the 20 people who liked apples but not oranges. This 23 could represent the people who liked oranges but not apples. And then the 10 here in the middle could be the people who liked apples and oranges. This is example 3.27 from the book. Suppose an experiment has the outcomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, where each outcome has an equal chance of occurring. If event A is 1, 2, 3, 4, 5, 6, which you can see here in the circle, and event B is 6, 7, 8, 9, which again you can see in the circle, then the probability of A and B, sorry, not the probability, the event A and B would be the overlap. That would be 6. The A or B would be all of these numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the 10, 11, 12 are going to be the ones that are not included in A or B. Okay, question 24. The Venn diagram shows the number of participants in 2 different kinds of aerobic exercise classes that are offered at a health club. So we can see that we've got step aerobics and jazzercise. If we add up all these values together, that's 60 people. And looks like 14 of those people are enrolled in both aerobics and jazzercise. 29 are enrolled in jazzercise only, and 17 are enrolled in aerobics only. So we would say if a person is selected at random from the participants, determine the probability that they are in aerobics and jazzercise. Notice that would be 14 of the 60 people. And then the second question was the probability of only aerobics or only jazzercise. These are mutually exclusive, so we can add the 2 individual probabilities together, and that would be the 17 over 60 plus the 29 over 60. See, now I have fixed it. 17 over 60 would be the step aerobics only. 29 over 60 is the jazzercise only. You can then add them together. Okay, next problem. This one has 3 overlapping circles. A survey was conducted at a local ballroom dance studio asking students if they had ever competed in the following dance categories: smooth, rhythm, standard. And the 5 people out here are the people who were at the ballroom dance studio but had not competed in any of them. So to find out the total here, you're going to have to add up all of these numbers. And after you add up all of these numbers, 5, 9, 12, 14, 13, 11, 7, 6, you end up with 77. If you added these up and you only got 72, 72 is correct for the 3 circles, but don't forget you have an extra 5 out here. So when you're working on your homework, don't forget to add that little bit of people who are outside the circles, because they're going to be part of the total. Okay, here are the questions. If a student is chosen at random, what is the probability that A, the student has competed in none of the categories? That would be the 5 out of 77. The student has competed in all 3 of these categories. That would be the 14 out of 77. Notice that the 14 is the overlap of all 3 categories. The student has competed in smooth or standard, but not rhythm. Okay, let me just go through these slowly. Hold on. Here's the first one. 5 out of 77, which would be a 6.5%. Notice the directions say, write your answers in percent form, round to the nearest tenth of a percent. So after I found the 5 out of 77, I turned it into a percent. 14 out of 77 is roughly 18.2%. Now this next one, smooth or standard, but not rhythm. So smooth and standard together have the 4 values in the purple plus the additional 2 values that are in the red here, and we don't want the rhythm ones included. So that means we're only going to be adding the 11, the 13, and the 9 together. And if you add those together, you end up with 33. So that's how you have 33 over 77. D, the student has competed in rhythm and standard, but not smooth. So rhythm and standard would be the 6 plus 12 plus 9 if we're going to exclude the smooth. Sorry, that would be rhythm or standard. Let me go back and point this out. In part C, we have smooth or standard. So that's how we end up adding together 11, 13, and 9. But in part D, we have rhythm and standard. And the and means we're looking just at this little overlap right here. And we're only going to use the 12. We can't include the 14 because we have to get rid of all the smooth values. So rhythm and standard overlap only here if we get rid of smooth. The student has competed in rhythm. Now this is all possible rhythms added together. 7 plus 6 plus 12 plus 14, that's 39. And that's how we're going to get part E. Okay, now number 27 is similar to this, but we've got different numbers. So now we've got a whole nother population here. So now there's 12 people who are outside of the circles, and the total for this one is now going to be something different than 77. It's actually going to be, well, it doesn't matter because we've got conditional probability. But okay, let's look at part A. The student competed in rhythm given they had competed in smooth. So what we're going to do is we're going to zoom in just on the smooth circle. Now if we look at just the smooth circle, this becomes our new population. 7 plus 13 plus 15 plus 4 is a total of 39. So of these 39 people who have competed in smooth, how many of them have competed in rhythm? And that would be the 13 and the 15. So that would be 28 out of the 39. So that's how we're getting this value here. Rhythm given smooth. Just look at the smooth circle and find the rhythm. Part B. The student competed in rhythm given they had competed in standard. So now we look at the standard circle and add together the 4, 6, 15, and 11. And we've got 36 total. Now if we look at this population of 36, how many of them competed in rhythm? It would be the 15 and the 11, right? So the 26 out of 36 would be rhythm given standard. And then next we've got the student competed in standard given they had competed in rhythm, which is the exact opposite of what we did in B. So looking at rhythm as your population, you've got 53 people. Of these 53, 26 of them competed in standard. And now for the last part, we've got the probability that the student competed in rhythm given they had competed in smooth or standard. So if we look at the sum of smooth and the sum of standard together, we've got a total of 56 people between the smooth and the standard. Of these 56 people, now we can look at 11 plus 15 plus 13. Those three numbers represent the ones that have participated in rhythm, given that they had already competed in smooth or standard. All right, so that's the end of the presentation. And if you have any questions, you can email me.